Okay, so welcome everybody to this week's Community Data Driven event, our session. This week we have Bobur. I'm not going to try and pronounce your surname. Did you want to say your name for me?
Yeah, hi everyone. My name is Bobur. English version is Tiger. You can call me Bobur or Tiger.
That's really cool. This session, just to make you aware, will be recorded. So if you don't want to be on camera or heard, please turn your mics off and your cameras off now. And we've got the QR code there, essentially, so you can look at our upcoming events and our website, but I'll go into that after this. Bobur is going to be talking about shaping the future of real-time data pipelines. We are part of the data-driven community. So you are attending a Cloud Data-Driven event, but we also have the Future Data-Driven Summit. So that is a conference that happens once a year. It's happening on the 24th of September this year. It is completely online and registration is currently open. So you can scan that QR code there and go to our website, register. And on our website as well, we also have any upcoming events for this weekly session as well. So please check it regularly, see if there's anything you want to attend, see if there's anything you're interested in. You're always more than welcome, and spread the word about our completely online event. So everybody's welcome, anybody from across the world, please let people know. So board members, so we have Jean Joseph, he's the original founder of the event. We have Ronan Ariely, and then we have myself. So the three of us organise this weekly event, and we are also part of the Future Data Driven Summit. But as part of Future Data Driven Summit, we also have a team of volunteers and other organisers to make the event happen. I am a Microsoft AI MVP. I have a background in data engineering, software engineering, and essentially anything LLM ops, ML ops. That's what I'm focusing on at the moment, what I'm working on. I'm working very heavily with Databricks, but also help a company called New Reader put together training material for lots of things in the realms of data. So that's us, that's the three board members. If you have any questions, concerns, want to submit a session even, please get in contact with one of us. We would be happy to speak to you. We're always happy to answer questions and always looking for new and inventive speakers. So don't be afraid if you are new to speaking. That is not a barrier. Please let us know and we can help you through the process. I'm going to to the next one. So, well, as part of this event, because we can have quite a lot of attendees, please use the chat to ask questions. At the end, we can, if it's a small amount of people, we can unmute and you can chat to the speaker yourself, but we don't want to be constantly disturbing the speaker as they are presenting their session. So please ask questions in the chat and we will monitor that as we go along. You're welcome to use the reaction button, so please feel free to clap, put your thumbs up, put a heart there for anything that you love. And finally, I'll finish speaking now and I'll hand over to Bobur to present his session.
Yeah, thanks, Sana, a lot. I think I should share again my screen, correct?
Yes, yeah, I'm going to stop sharing.
Yeah, let me take over the screen, and here we go. Let me know if you can see my screen.
Yeah, we can see it.
Very good, very good. Yeah, hi everyone, once again, welcome to my session. I'm super excited actually, and my great thanks to Ronan and Jean Joseph. They invited me to speak at this event. I'm super excited because I'm also with a strong data engineering background, also as a software engineer. This talk actually demonstrates how to shape the future of real-time data pipelines. We're going to implement cost-efficient, like auto-scalable, serverless streaming pipeline infrastructure by eliminating the need actually to build an infrastructure for your basic or complex data pipelines. With that, let me again I'll talk about myself a little bit. I'm a developer advocate at the company called Glassflow. We are a Berlin-based startup company, and I'm also ex-Microsoft. I work at the Microsoft as a developer audience lead for Central Eastern Europe in the past, and this year I was nominated as MVP for Azure AI Services, as Anna also in the same field as I heard. Please feel free to reach out to me on LinkedIn by scanning this QR code. Feel free to interrupt me anytime if you have questions regarding these sessions, or if you'd like to learn more about AI in Azure or data, real-time data streamings, or Python-based streaming frameworks. I will be more than happy to address your questions. So, and one of my hobbies, I like to speak at events. Perhaps the last year, in 2023, I delivered 70 sessions in person and online in 35 different countries, mainly in Europe and US, and some part of UK as well. My surname was interesting. Umurzokov means live more. Bobur means tiger, which means tiger who lives longer. I think this way much better to remember my name. So let's get started. Our story actually begins with a data engineer like you. His name Bob Dreamer, who works at a medium-sized company called Dream Together with more than his 50 colleagues. And what they're building innovative car-selling online platform where their users can register their cars or vehicles and announce their vehicles to buy or sell, just like an online typical car-selling platform. And Bob was highly motivated by the recent AI hype since everybody around him talking about AI. He comes up with a brilliant idea of creating a real-time price recommender solution for their existing website using modern data tools. How it works, as new cars are registered in their primary database. In that case, they are using, assume, PostgreSQL, just a traditional database. And the app should suggest a price for the vehicle using large language models, in our case, LLMs. This application also needs to run in real time so that users can quickly receive appropriate feedback from the web application or maybe from the mobile application. After he presents his idea to the team, and the team was curious about the outcome because they have a very limited number of employees, just they're establishing data engineering teams, and they give some time to Bob to create a proof of concept for his idea. So, and because of his knowledge mostly on batch processing, he starts to investigate what is actually stream processing, right? We know that only real distinction between batch processing and stream processing, how they operate at slightly different time intervals. For a long time, inflexibility of batch orchestrators, schedulers pushed the data teams to maintain two separate systems, how to satisfy some modern event-driven and real-time data workloads for streaming data. But it doesn't have to be that way, right? And then Bob starts to Google and ask GPT to learn more about stream processing. As you can see in the diagram, this is a real-time data processing pipeline architecture, which has a set of tools, technologies available today. This is the area where rapid changes are also happening, right? And each of these tools and technologies, of course, has a certain strengths when it comes to the particular scenario, but in general, how they work. You just ingest the data or real-time events from data sources on the left side. Data source can be any traditional database or event brokers like a Kafka, or message queues like Google pops up, or maybe streaming services like in AWS Kinesis, or even in Azure, Azure Event Hubs, right? And then you process data in the middle to somewhat like aggregate your data, filter and enrich with additional, or run some ML models, and you send the output to the destinations. What about destinations? Destination, we know data lakes, it can be data warehouses or any real-time analytical services. So once he understands what's the real-time data processing pipeline, he starts to, again, like discovering and how he can come up with first solution for his proof of concept. This is a solution Bob thinks as a first solution for the use case where predicting car prices, where he used the Bayesian to capture database changes basically from the PostgreSQL and stream these events via Kafka to the prediction service, which is just a Python script. And this prediction service itself connects to the OpenAI API to calculate the suggested price using AI. And the enriched data can be also sent to the output to the web application. Very simple architecture, right? So where you can see Kafka, the Bayesian OpenAI API, or Azure OpenAI API. You can use exchange any models you can use for predicting the prices, or you can even use ML models. But however, you see, Bob faced several challenges even in this simple solution. First of all, he lacked the experience with Kafka, and he didn't want to deal with infrastructure complexities because of time concentrators. He doesn't want to learn Kubernetes. Data engineers sometimes should also learn and deal with how to work with Kubernetes, right? His goal was also to implement everything in pure Python, because he knows only Python. He doesn't know JVM or Java programming languages. And he also wanted to ensure the multiple data pipelines, or at least single data pipeline he creates, can be collaboratively work with other team members. He can share his pipeline, and others also can contribute to the pipeline. And finally, he needs the product service also automatically notify the web and mobile application in real time. This is I think, #1 requirement for the solutions, right? If you are part of data team, you're more likely to know like Python. It's kind of go-to language for AI and machine learning. So because of these challenges, he starts to think about what else he can do instead of using Kafka and dealing with Kubernetes or infrastructure complexities to build a single proof of concept. He asks his real data engineer friends around him instead of asking Google or GPT. And Bob hears a lot of stories from Kafka users about taking the 9 months to implement the Kafka-based production-ready data pipelines. They see some customers having 50 teams relying on a single Kafka cluster, managed only by one person, or data engineers on the side cannot simulate easily a production environment without complex initial setup, as you can see for predicting prices. Sometimes data scientists also struggling with data integration, building offline ML pipeline to easily experiment or at least reproduce models locally or debug them to understand what's going on there. And actually, one of the dependency of the data engineers, they are highly depend on external teams such as DevOps teams. Often they ask DevOps teams to provision some Azure or cloud resources for deploying new data pipeline, which is obviously creating some delays in the project, right? Nowadays, modern data teams, they want self-sufficiency, only using the Python, forgetting about the infrastructure. So Bob collects all these pain points and ideas from his friends, and he writes a blog post to share his knowledge with people like in this event and around the world. If you scan this QR code, you can find the information about Bob's observation. What are the top 10 common data engineers pain points in 2024? Just please scan the QR code, and you can read also this article, quite interesting, like categorizing some problems. So in Bob, as you know, from the beginning, he's a dreamer. one of his dreams, he shows, what about Bob? Can you try stream processing frameworks in Python, which is nowadays modern technology based in purely in Python. And he discovers and starts focus on when and why he can use stream data processing frameworks for Python. As you can see in the diagram, above like a Python-based framework unifies a streaming data platform. On the other side, the stream processing components in this data pipeline architecture. You can connect directly to any data source on the left side using built-in connectors within your application code without knowing how the Kafka or other message brokers work. You can only focus on the business logic. On the other hand, modern stream processing frameworks in Python combines two well-known tools, Kafka and Flink. Because if you're building well-advanced data pipeline, you need to use these open source technologies, Kafka such as Flink. So, and he starts asking himself question, okay, now what kind of Python frameworks we have currently developing in the market? There are some, of course, stream processing Python libraries, or we call it wrapper classes on the top of Kafka. But the frameworks, they are different from libraries. Frameworks have been developed to cope with the challenges that Python engineers or data engineers facing with the Python-based interface for Apache Kafka or Flink, since we know both do not support natively Python. And also in addition to a few weeks of learning Kafka and Flink, if you are using libraries for Kafka means as a data engineer, you cannot directly use Python, let's say pandas libraries, which is very famous library. You need to implement always custom transformation functions like UDF to convert your pandas function to Java syntax. This translation time can significantly impact on the overall responsiveness of your real-time data. Assume that getting a Python pipeline in production takes from 6 to 12 months, involves a lot of collaboration between different types of stakeholders. Like you need to have a DevOps dedicated person, you need to have a Java developer, you need to have again other stakeholder who's responsible for one small part of your data pipeline. And also Python frameworks can be used out of the box with any existing Python library, right? You can use with pandas, you can use with Flask, NumPy, and so on to connect to hundreds of data sources. You can use the entire Python ecosystem for data processing. And they're much easier to get started because you just need to install Python library using pip or any dependency management in Python without complex initial setup, like such as creating competing clusters if you're using JVM or Kafka case, or they can also manage your data in the application layer, which is really important, where we don't face, again, these data inconsistency issues. Where you can maybe use a change data captures like the Bayesian, still directly connect into your primary database, do computational work in Python application, and save the result back to the primary database, or send the real-time data to the output streams to your destination. And most importantly, what I like when using frameworks purely in Python, they make it easy to launch multiple case-by-case data scientist projects in Jupyter. You can run multiple data pipelines on multiple Jupyter notebooks to understand like which one is better performing, or they are actually eliminating building separate data pipeline infrastructure for each Jupyter notebook, correct? And some of them obviously offer some serverless platforms where resource management, operations, or scaling completely taken care of in your environment if you're using public clouds like AWS, Azure, or Google. From my perspective, like if you're using also Python frameworks, it's also the right tool for building complex real-time data pipelines where you have multiple stages for the transformation, where output of one stage always input to another, and you have a complex even processing rules. Because in Python, you can define any complex transformation rule for your pipeline. That can be a very good example for user use case. So let's have a look. Once we understand like a Python streaming frameworks can be useful, and in Bob's scenario, how exactly it fits in his architecture. Let's have a look at some use cases, maybe 3 or 4. First of all, let's think about event-driven applications like microservices, where application decomposed into smaller components, where independently scalable. They usually communicate with each other through the events. And actually, these Python frameworks can maintain asynchronous communication for microservices easily in the application layer again, as a middle layer service between 2 different microservices. Another use case, they usually streamline process of capturing, transforming, loading event-based data into the way of house in continuous and real-time manner. As you can see in this picture, we are building ETL pipeline for continuously updating any data warehouse or machine learning platform. If you think about like AWS framework for machine learning, or in Azure, you are continuously updating real-time data your machine learning platform. Third use cases, also for popular, like for AI use cases, what about building pipelines for processing real-time events, extracting vector embeddings in real time from LLM models via transformation function, and continuously updating your vector database. The same use case nowadays, you can see a lot of like blog posts around vector databases. So this is some architectural use cases. Now think about real world scenarios. Here I'm bringing one real world scenario I have faced myself while I was talking to HP company. Assume that there is a HP printers. You would like to predict the future ink consumption based on some real-time data and historical data. And you need to also send some real-time notifications when one of the printers ink level is lower than expected threshold. In this particular scenario, you can use also Python frameworks or serverless streaming pipelines to build a solution that identifies in real time the ink level and also notifies by email or by on the Slack about leakage for the ink levels. Another real world use case which is a very famous, think about Zipcar, Miles, Bolt, Lyft, all the mobility car sharing projects companies. They can also leverage this kind of Python framework to process real-time ride events from maybe real-time API. They can monitor the full consumption, or you can also manage some supply of car sharing in a more optimized way. You can send some data to the driver, like information about nearest full station. And once you find the nearest fuel station, you can also make a discount to the driver, because depending on the location, he or she can bring the car to the fuel, and then based on the proximity of the nearest fuel station, you can get some discounts for the future, or send some output to the again, like warehouses, other real-time databases. So this is the real world use cases, and other fields also getting benefit from using Python frameworks, like in travel, logistics, or advertising, and so on. So now Bob understands some real world use cases, architectural use cases, concept, and so on. And finally, he meets a developer advocate, Bobur, at one of the developer conferences. He explains his findings, pain points, what he would like to achieve around this predicting car price. And Bobur starts to explain, hey, Bob, have you ever tried like a serverless event streaming as architecture? Let me explain to you. And then Bobur explains to Bob, let's define this architecture, how it looks like. It's a serverless stream processing pipeline. Here, as you can see, with a couple of components, the same framework, but it's running in the server in the cloud, right? You can deploy to your cloud, but in reality, Bob can define a new stream processing pipeline using a web application or using a CLI function. He can upload a transformation function to serverless execution engine, whereas this transformation function runs continuously and scales automatically without managing Bob himself. And Bob also can connect to live data sources using, again, Python SDK, maybe with the help of built-in connectors like the Bayesium. And the connectors captures every change on a primary database, and then maybe also use OpenAI API to do some computational and to get the AI insights, and saves the result back or sends the output to the destinations. The same like the way how we discovered like this simple architecture. How it works internally, this serverless stream processing architecture. It has some separation, like as you can see in the diagram. Pipeline management is independently working with data management, like you are creating your pipeline programmatically or using UI interface. Then you can also bring your internal message broker on your own. Internal message broker can be like the same Kafka or open source technology like a NATS. I'm going to talk about more soon. And serverless execution engine, you can use any sort of like a serverless solutions in your mind. And then you can use Python SDK to publish some events and consume some events on the consumer side. So as we were thinking about the stream processing architecture with our existing team at Glassflow, we decided to build also our own Python framework that does similar architecture. Where you have a code for development with fully managed serverless infrastructure to build your streaming data application and deploy and run scale for the production use cases. As you can see, there are some source connectors and sync connectors. You're using purely Python, and you are uploading a transformation to the serverless execution engine. Then the pipeline runs without you are managing the infrastructure. Technologies under the hood, I'm going to show, of course, like this framework soon with the demo that I have. As you can see, it's built using robust technologies like NATS and Kubernetes and Docker. Obviously, we know the reason why Docker Kubernetes to deploy some containerized application and serverless solutions. So once we understood, okay, this is serverless stream processing, Python frameworks, and so on. So Bob finally, now for his second first proof of concept, but second solution, he knows what to use. Then now Bob, we're going to explain how to start with for his predicting car price pipeline. Let's see together. First, you start with defining your custom transformation function, because as we remember in the modern stream processing pipelines, always you need something in the central data transformation. Data transformation can be any of these in the screen, like you either normalize the data, or you do some anomaly detection, or you connect to real-time APIs, you integrate to ML models. In Bob's case, he's doing data enrichment, right? He's doing data enrichment using AI to predict the price. Then once he knows how it looks like the transformation itself in Python, he writes some code in Python and connects to the live data sources like the Bayesium in a Python SDK, and he creates a pipeline using CLI. Then this transformation runs in real-time data, and it's ready to consume. How it looks like a second architectural solution like this. It's even much easier than the first solution. Obviously, we are not using Kafka, we are not learning Kubernetes, we are not implementing anything like custom solution here, but you can customize easily data transformation part and how you're capturing data and how you're sending the data to the output. So first, now in the demo I'm going to show soon, we create a new transformation. We write a Python code to transform this incoming data, and you will see how the function is parsing JSON data coming from PostgreSQL, and how we are predicting the car price using OpenAI API. So it's finally enough theory, enough concept. Let's jump on a short 5 minutes demo. If you scan this QR code, you can also find the code on GitHub repository. If you miss the demo, you can always try it yourself to understand which the solution number 1 or solution number 2 easier and faster to develop, and it's scalable. So let me jump on another screen now to start with the demo. Then we can also leave some time for your questions. If you scan this QR code, it will bring you to the following GitHub page. Hopefully you can still see the screen. This is a simple like a folder where I can see some Python scripts for producers. And currently I'm using just the fake data, but obviously you can use some connector, built-in connector to connect to database and PostgreSQL data that generates some fake data about the car price information. I'm going to share also actually to the real branch where I can connect to PostgreSQL as well. Then there are some code to send these records in real time to the Glassflow pipeline that sends the data obviously to transformation function. And we have in the middle, if you remember the architecture, we have transformation. It's also very easy. Transformation, what we do, we are connecting to basically to OpenAI API to use the chat completion endpoint to build some prompting. We are sending some prompt to ask AI, please use this input every time for every event and predict the price for the upcoming data JSON events. So yeah, then we have a consumer. Also it's very simple. After transformation happens, we are taking the data from the pipeline again. We're just writing the output to the simple text file. So this is a kind of simple explanation of this solution. And if you open, for example, car data price text file, you can see suggested price appended for each input event coming from PostgreSQL. We are assuming that we are using a PostgreSQL. As you can see, using the AI, it's suggesting some price for the car. Let's test it out. So I'm going to jump on this VS Code, or we can use also even the CLI. Let me come back. Yep. Let's use the CLI to poorly understand how we create a pipeline and how we build our pipeline for predicting car price. Let me actually switch to the folder with examples. Go to predict car price. Now I'm on the same folder that GitHub repository has. Then the first command I'm going to use is to create a space. Space is just the container that keeps multiple data pipelines inside the space to manage your resources efficiently, or even you can share that space with your other data team members, how they can elaborate with each other. Everything can be managed inside the space. Let's create some space, call it examples. This is a simple command line, how it looks like. I'm going to create a new space called examples and click done. I will get as a result like some space ID. Now, next step is I'm going to create actually a pipeline to inside this space to use some sort of transformation function. How it looks like, something like this. I am also defining transformation Python script. If you remember, there was a transform.py on the GitHub repository. Then I am giving the name for the pipeline, like a product car price. So then I'm going to copy on the space ID, put on the terminal here, replace with the space ID, then click enter. Here we go. Now pipeline is created fastly, and now actually the transform.python script deployed to the cloud. In our case, we are using Google Cloud. It's now is running as a serverless function. And this transformation, you don't have to manage yourself. It's already, everything is managed by the infrastructure itself. So now our pipeline is ready. It's time to test it out. Next step, I need to jump on my VS Code and collect some environment variables like a space ID, pipeline ID, and XX token. This is actually credentials from my old pipeline. I can remove them, then bring all the data I have on my terminal. I need a space ID, obviously. Then I need a pipeline ID. I'm going to copy that as well. Here we go. And then finally, the token. Yeah, please do not try to hack the pipeline until we finish the demo. Then I will just clean all the tokens for the demo case. So we're good. Now, environment variable has some pipeline configurations, and I can run now producer and consumer Python scripts. Let's run producer to produce some pipelines. Actually, I can also run, because I need some libraries installed beforehand, like Glassflow. As in this case, it's installed inside the environment. Let me use my environment in this case. Let's clean that screen and go in your terminal. Here we go. I can go to use cases from the conference. Single use cases, the Fireflies and Python producer. Let me run first producer. Here we go. Yeah, now producer in real time producing real-time data changes. In our case, let's say new entry is added to the PostgreSQL database. I can open another tab to demonstrate the consumer part. Let's see what's happening on the consumer part. Python 3 and consumer, here we go. Then consumer part also starts to consume some data in real time from the Glassflow pipeline. Then it should save some output data to the text file. In our case, let me take a look what's going on here. Something happened probably. Let's stop too many requests and wait a little bit of time to receive some real-time data from the consumer part. We can also, let's see what's going on. When it comes to demonstration, always happens something bad. Yeah, obviously, this transformation, we can also have a look at the logs and observe some issues. Let's see what's happening. I can also go to the dashboard and see the logs. Yeah, here we go. These are some errors happening in the transformation part. Let's see. Yep, here we go. We have discovered the issue. There was no model called OpenAI. Now, because every transformation function, actually, it was good that we discovered every transformation function requires some custom libraries you would like to use, correct? Like I can use external libraries, but because since we are deploying in this transformation to the serverless execution engine, we need to explicitly specify which external libraries we would like to use. Let me specify them. Let's say I should have another command to specify I would like to use OpenAI API. Let me do so. There should be, yeah, here's requirements. Probably I forgot the additional parameter in the requirements. Let's do some updates. I can also update my pipeline. Let's do that. Runs again this with additional parameter. I will run. Let's test it. Here we go. But in this case, I created additional pipeline with a new transformation function. Let's update. Pipeline ID replace it. And actually, you can also update transformation function without creating pipeline. In my case, just to make sure that everything's working, create another pipeline by running again the same command. Let's push some more data once again, and we can test it out. Producer, let's go. And consumer, let's go. Let's see what's going to happen. Hopefully, it works well this time. If not, then I will see again what's going on the logging side. See some errors. Yeah, a model name info, but we replaced it already the OpenAI function. Let's see again. Maybe it starts actually deploying. Let's see. Go ahead and run again. Maybe it's assuming still like using old the pipeline itself. No, it's still discovering. Let's do it once again. Let's make sure that I created, requirement OpenAI there, space there. Let's do that once again. Maybe it helps to run this pipeline. Just before the session, it was working fine. Now, somewhat, it start to fail because the additional OpenAI library is not accepting us. The price, let's do some producer and do consumer. Last try. If not, then I will leave it to you after I fix the repository, then you can give a try. In reality, we should expect like also once the producer produce data, I need to consume transformed data. You should be able to see on the screen also transformed data also on this file. Basically, you should get the suggested price, something like this, after you connect to the OpenAI API. So we'll leave as it is. I'm going to fix that and ping you on the chat. We can also discover later like what's happened with the demo. So let me jump on back to the presentation. Let's go. We can keep some time. Let me share once again my screen with the slides. There you go. Yes, we are here. Then go to end slide. We have a little bit of slides left, and then we can jump on a Q&A session. Right. Yeah, please come to Discord code. We can have a look what happened later on. So actually, what was the idea of this presentation? I want to prove that not only the glass flow, but using a Python frameworks, actually, you can improve a little bit of latency, not considering the fact that there was some errors. Without improved latency, it actually does. You can also reduce some cloud computing costs if you're using frameworks. You can easily integrate data sources if they support any built-in connectors or not built-in connectors. And you can also transform some billions of records efficiently without worrying about infrastructure. So with that, like Bob was able to run his data pipeline from day one, again, like without considering the issues with the way that we have. So, and Bob's solution number 2 is ready to present his team. So in the summary, what I would like to say, Bob's challenges was actually, as a data engineer, the problems with GVM-based real-time processing tools nowadays, because of the complexity, because of the learning curve, it is so difficult still to build the data pipelines from scratch. And what Bob's wanted to be as self-sufficient only in Python. So, and he found some solutions like using a stream processing framework in Python. And to forget about infrastructure, he used some streaming serverless solution for his pipeline. So with that, we can smoothly jump on a Q&A session. If you have any questions, I will be more than happy to answer that questions. But in the chat, please let me know which solution is much better, like solution number 1 or solution number 2 for predicting car price. You can also observe other the examples I provided in the same GitHub report. There are a lot of use cases, like how you build real-time clickstream dashboard, or how you do a data anomaly detection in real time using the serverless architecture. So now let me check the chat if there are any questions. See. We got one question. Another main challenge when, let me read it through. Another main challenge when using Python with PySpark, maybe other unit testing the logic before deploying to production. It's not always easy to perform even debugging and developing locally. Is it something that Glassflow supports? Thanks, Lionel. That's a good question. Yeah, this is actually number one issue we are trying to solve, that unit testing or actually in general like testing, it's not shouldn't be kind of hard for data engineers because like you're using Python, you can do unit testing for every steps of your data pipeline, starting from consumer part and producer part. Obviously, if you're using connectors that we support, you don't have to worry about testing. You can only focus on the transformation part, and then you can try to test the transformation logic with unit tests or integration tests. But in general, we support this feature. You can have a look at the website. We are still like a closed beta version. That's why I'm not like gonna kind of do marketing and pitch here. All these samples are open source code samples, but you can also create your user account. It's for free. There is no currently limit on the number of events you are sending to the pipeline. Just for testing, it's still good. You can try out end-to-end pipeline solution quickly. I hope that answered your question. Thanks a lot, Lionel. Is there any other questions? So let me know. Let me also put the repo link with other use cases here, including product car price. You can have a try. So other than that, if there are any other questions, the last thing I would like to show, because we faced some issues on the seller side, maybe probably there was something like deploying now, but it should be smooth. It should become smooth again. You can also use even the UI to create your pipeline without CLI. Obviously, you can just go through some steps, defining your producers. You can even upload the transformation function here, or use any default transformation or sample transformation. With easy next steps, you can create your pipeline easily if you prefer like zero code style creation of the data pipelines. Thanks a lot. I think we are good. Hopefully on time. Sorry if we're running out of time. Anna.
No, we're good. That was really interesting. Yep, that was brilliant. Thank you.
Yeah, thanks.
Yeah, sorry, I was just trying to share my screen. Just give me a second.
I can stop my sharing, sorry.
That's all right.
Yeah, take over the screen.
Brilliant. Okay, thank you so much for that, Bobur. That was really interesting. Please reach out to him on social media if you want to ask him any more questions. This session is recorded, so we will be putting this live with our other sessions that we record, so that you can watch it back or tell people about it and see if they want to watch it as well. So yeah, thank you so much. Just a reminder that we have these sessions every week. We have the Future Data Driven Summit coming up on the 24th of September. Ronan put the link to that in the chat. So if you like attending conferences that are completely online, or if you like myself, you have trouble actually getting to different events, Future Data Driven is really amazing. We have kind of over 50 sessions, lots of amazing speakers, and you can do it all from the comfort of your home. So please check it out. And yeah, thank you so much. Thank you everyone for attending, and I hope you have great rest of the days or great evenings if you're in the same time zone as myself.
Yeah, thanks a lot. Take care all. Thanks, Anna.
Thank you.
Thank you.